Hello students, I welcome you all to the session on design and analysis of algorithms. In today's class, we will dive into the first unit. First unit is about algorithm analysis techniques, and this is the topic that we are going to cover in our first unit, including the notion of an algorithm, then what are the two different types of algorithms, how we are going to analyze all those algorithms, and about the string algorithms. Now, let's dive into the first topic. So, first topic is about what is an algorithm and about the notion of an algorithm. So, first of all, we will see what is an algorithm. I think you all might have studied about this algorithm and its characteristics in your first semester itself. So, actually, an algorithm, it is a step-by-step procedure or a set of well-defined rules, or we can say it as instructions that are followed to perform a task or solve a problem. Actually, it is a sequence of operations that take input, process it, and produce the desired output in a finite amount of time. So here we have the input, then this input is provided to the algorithm. This algorithm is nothing but it is a set of rules to obtain the expected output from the given input, and from this we will be getting the desired output. Next, we will see what is the need for an algorithm. Actually, an algorithm is designed to develop a framework for instructing the computer to perform the tasks, and also it is used to introduce notion of algorithm as a means of specifying how to solve a problem. And also the third need of the algorithm is that it is used to introduce approaches for defining and solving complex tasks. Next, coming to the characteristics of an algorithm. So the characteristics are being mentioned here. First characteristic is finiteness. So an algorithm must terminate after a finite number of steps. It should not go into an infinite loop or process indefinitely. If an algorithm does not halt after a finite number of steps, it is considered flawed. Second characteristic is clear and unambiguous. Each step of the algorithm must be precisely defined. The instructions should be clear and unambiguous with no room for interpretation. Every operation should be well understood by the machine or the program. Third one is well defined inputs. An algorithm must have zero or more inputs. Inputs are the initial data or conditions that the algorithm will process. These inputs are provided to the algorithm, and the algorithm will work on them to produce an output. Next characteristic will be well-defined outputs. An algorithm must produce at least one output. The output is the result or solution derived from the inputs after applying the algorithm's steps. And also, the output must be well defined and consistent given a particular input. Coming to the next characteristic, finiteness. Finiteness characteristic of an algorithm means that the algorithm must always terminate after a finite number of steps. In other words, an algorithm should not run indefinitely. It must halt after performing a specific number of operations and produce an output. Last but not the least, we have the feasibility of an algorithm. Feasibility refers to whether an algorithm can be executed with the available resources such as time, space, and computational power. A feasible algorithm is one that can actually be implemented and run within a reasonable amount of time and space for the given problem. So this is all about the different characteristics of algorithm. Next, we will see the steps involved in an algorithm. So first step is design of algorithm. Second one is expression of algorithm. Third one, correctness of algorithm. Fourth one, analysis of algorithm. And last one is testing of algorithm. So we will now see an algorithm just for making a cup of tea. So An algorithm is nothing but we all know that it is a step by step procedure for performing a particular task. Here, the task is to prepare a cup of tea. So, the step by step procedure is being given here. First step is to gather the ingredients and equipment. Second step is to boil the water. Third step is to prepare the teacup or mug. Fourth step, pour hot water. Then comes the tea. Remove tea bag or strain tea. Add sweeteners or milk and enjoy your tea. So these are the step-by-step procedure which is used to complete the task of preparing a cup of tea. So this is what we refer to as an algorithm, and this algorithm is being converted into code by using any one of the programming languages, and here the code is being given for the task to prepare a cup of tea. Next, another example for an algorithm is for finding the largest number. So here we have the input as list of numbers L and the output as largest number in the list L. So the step-by-step procedure which is used for finding the largest number is being given here. Initially, we will be initializing the largest number as null, which means that 0. And for each and every item that is present in the list, what we will do is that we will compare if the item is greater than the largest. Suppose if the current item which we have considered is greater than the largest, then what we will do is that we will assign the current item as the largest and we will return that particular item as the largest item. So this is an algorithm for finding the largest number, and the code for implementing the largest number from a list of numbers is being specified here. So here we will be getting the number input number from the user, and after getting the input number from the user, what we will do is that we will initialize the first number as the largest number, and then we will compare those and that largest number with the remaining items that are present in the list. Suppose if any other number is found to be larger than the first number which is being initialized as the largest number, then that item will be initialized as largest and that will be stored as the largest element. Next, coming to the notion of an algorithm. So this is the notion of an algorithm. So here the notion of an algorithm refers to the abstract concept or idea that represents a sequence of steps or rules designed to solve a particular problem or perform a specific task. Algorithms are fundamental to computer science, mathematics, and many other fields as they provide a structured way to approach problems systematically. Every step of an algorithm must be unambiguous, meaning that each instruction or operation must be precisely defined and clear with no room for interpretation. The set of inputs for which the algorithm is designed and expected to work must be clearly specified. The same algorithm can be expressed in different ways using various forms such as pseudocode, flowcharts, or actual code in programming languages. There may be several algorithms that can solve the same problem, each with potentially different approaches. So, coming to the Euclid's algorithm is based on applying repeatedly the equality GCD of m comma n is equal to GCD of n comma m mod n, where m mod n is the remainder of the division of m by n until m mod n is equal to 0. So here we will consider finding out the GCD of two integers 60 and 24. So this GCD can be found out by using the formula that is being given here, GCD of m comma n equal to GCD of n comma m mod n. When we apply this to 60 and 24, we will be getting GCD of 60 comma 24 which is equal to GCD of 24 comma 12, and that in turn is equal to GCD of 12 comma 0, and we will get the final GCD value as 12. And these are the steps or the step by step procedure which is used for computing GCD of m comma n in Euclid's algorithm. First step is that if n is equal to 0, return the value of m as the answer and stop. Otherwise, proceed to step 2. Step 2, divide m by n and assign the value of the remainder to r. Step 3 is assign the value of n to m and the value of r to n. Finally, go to step 1. So this is the algorithm. So basically in an algorithm, we will be having the algorithm description. So here the algorithm description is nothing but it computes GCD of m comma n by Euclid's algorithm. Then we will be having the input and output that will be specified, and finally we will go with the basic logic of this particular algorithm. Here the basic logic is to compute the GCD value of m comma n. So while n not equal to 0, just do calculate the remainder. So remainder will be calculated by using m mod n formula. And after calculating the remainder, we will assign the value of n to m and the value of r to n. Again, we will proceed with this calculation, which is m mod n calculation, until the value of n is equal to 0. Once the value of n reaches 0, then we will return the value of m as the greatest common divisor. So next algorithm for finding the GCD of m comma n is consecutive integer checking algorithm. Here the steps, we have four steps. First step is that we assign the value of min of m comma n to t. Second step, divide m by t. If the remainder of this division is 0, go to step 3. Otherwise go to step 4. Step 3 is divide n by t. If the remainder of this division is 0, return the value of t as the answer and stop. Otherwise proceed to step 4. Step 4 is decrease the value of t by 1. Go to step 2. Next, again one more algorithm for computing the GCD value of m comma n as middle school procedure. And middle school procedure steps are being described below. First step is to find the prime factors of m. Second step is to find the prime factors of n. And third step, identify all the common factors in the two prime expansions found in step 1 and step 2. P is a common factor occurring Pm and Pn times in M and N respectively. It should be repeated. Min of Pm comma Pn times. Step 4. Compute the product of all the common factors and return it as the greatest common divisor of the integer. So here we have the numbers 60 and 24. So we have computed the prime factors of 60 and 24, and we have found out the common prime factors for 60 and 24. Here we can see that the common prime factors are 2, 2 and 3. When we multiply this, we will be getting the value 12, and that will be returned as the GCD of these two integers 60, 24. Then coming to sieve of Eratosthenes. Okay, so this sieve of Eratosthenes actually it is used for generating. The basic idea behind the sieve of Eratosthenes is that it is used to iteratively mark the multiples of each prime number starting from 2. The numbers that remain unmarked after processing all the possible primes are referred to as the prime numbers. And also the sieve of Eratosthenes is an ancient and efficient algorithm which is used to find all the prime numbers up to a given limit, which is referred to as n. And also, this is an algorithm for generating consecutive primes not exceeding any given integer n greater than 1, as we already saw. The algorithm starts by initializing a list of prime candidates with consecutive integers from 2 to n. Then, on its first iteration, the algorithm eliminates from the list all multiples of 2, that is 4, 6, and so on. Then it moves to the next item on the list, which is 3, and eliminates its multiples. So here we will have an example. When the value of n is equal to 50, we need to find all the prime numbers that are smaller than or equal to 50. So here we create a list of all numbers from 2 to 50. So these are the list of numbers from 2 to 50, and we are going to find out the prime numbers from this. So according to this particular algorithm, sieve of Eratosthenes algorithm, first we will mark all the numbers which are divisible by 2 and are greater than or equal to the square of it. So once we mark all those, then we will mark the numbers which are multiples of 3 and are greater than or equal to the square of it. Again, we will mark the number 5 and mark all the multiples of 5 which are greater than or equal to the square of it. And at last, our final table will have all the unmarked numbers as the prime numbers that will be generated between 2 to 100. Thank you.